Hi Math 2 students, and welcome to your 6.3 Day 2 notes. So let's kind of go over a couple definitions. It says, remember if two polygons are similar then. So their sides are proportional. We will say they're corresponding. And what that means is, remember how when we would set up the proportions, we put like the corresponding sides together, set them equal to each other, and solve. Okay, that means you're allowed to do that. And then we also know that their angles are congruent. Their corresponding angles are congruent. So far, we've just been kind of told that triangles are similar, but sometimes you have to prove, you have to show, hey, these are similar. And there's three ways to prove that triangles are similar, all right? We have angle, angle, we have side, angle, side, and we have side, 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 all right? We use this little symbol here, the squiggly line, to distinguish between similar and congruent. So congruent, we use a squiggly line with an equal sign. That means they're the exact same size and shape. Similar means that they are the same type of shape but a different size. Oh, sorry. All right, so we have angle, angle, which is AA. It says if two angles of one triangle are congruent to two triangles of another angle, or two angles of another triangle, then the triangles are similar by angle, angle. All right, so for example, if they told us that these two angles are congruent, and that these two angles are congruent, you can prove it by angle, angle. As soon as you've got two angles congruent, you can say it's similar by angle, angle. All right. Then we have side, side, side similarity. If two corresponding sides are proportional and the included angle are congruent, then the triangles are similar by side, angle, side. So we could do, we'll like highlight, we prove that these are proportional. These are proportional. And then you would have to prove that these that these angles are congruent. Okay, it has to be that angle that's included with the two sides that you've proved. Let's say you showed that, I'll do it in a different color. Let's say we had the red and the orange side, and instead you showed these angles congruent. That doesn't work. All right, you have to have the angle be in between the two sides that you just showed proportional. Then we have side, side, side similarity. So if all three pairs of corresponding sides are proportional, then the triangles are similar by SSS. So we would need these to be proportional, these to be proportional, and these to be proportional. And we've learned how to set up proportions, but I guess we haven't really talked too much about how to prove something is proportional. And we'll talk about that now. All right, so here it says, is ABC congruent to X, Y, Z? All right, so let's take a look. They're saying, okay, we got AB, and AB goes with XY. All right, so let's label triangle 1 and triangle 2, and we're always going to do triangle 1 over triangle 2. All right, so we're going to do 6 over 4. Then let's do, they say BC, and BC is going to go with YZ. So we've got 9 over 6. And then we've got AC. Well, that's not a highlighter. And we've got XZ, AC, XZ. All right, and that gives us 12 over 8. All right, so what you're essentially trying to do here is make sure that these proportions are equivalent. And how can you do that? There's a couple different ways. To me, the easiest way is to just divide these on your calculator and get the decimal equivalent. So if I do 6 divided by 4 on my calculator, whoops, 6 divided by 4, I get 1.5. When I do 9 divided by 6 on my calculator, I get 1.5. And when I do 12 divided by 8 on my calculator, I also get 1.5. So since these are all equal, you can say that this is similar by side, 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 because we showed that three sides are proportional. All right. Now, If we had calculated these proportions and just one of these didn't give us the same number as the other two, then we wouldn't be able to say that they're proportional. All right, so you have to make sure that when you divide, you're getting the same value every time. All right, so let's take a look at these two. So I'm looking and I'm like, okay, well, I know I'm gonna have to try and prove these similar, all right? And I'm looking at this, and the method I'm gonna attempt to use is side, angle, side, right? Because we have a side, we have an angle, and we have a side, all right? So that's gonna be our attempted method here. And we know that AC goes with XZ by our similarity statement. And then we also know that CB goes with YZ. All right. Now, obviously, these angles are already congruent, so we've got our angle of our side, angle, side, but now we need to show that the sides are proportional. So again, we'll label triangle 1 and triangle 2, and we'll do 6/3, and then 10/5. When I plug this in on my calculator, I get 2 and 2. These are equal. So yes, these are similar by side, angle, side. And I guess we could write yes. All right, so let's try C. So C looks pretty similar to the one we just did. We've got AB, XY go together. And again, you can use the similarity statement they gave you. And sometimes they actually won't give you a similarity statement, and there's a specific way you can go about that. And we'll eventually talk about that. So in this case, we followed along with the similarity statement. Let's label this triangle 1 and triangle 2. We've got 8/5, and we've got 4/3. And looking at this, I am going to attempt to use a side, angle, side reasoning for this. So we've got obviously that these angles are congruent, so now we need to show that these sides are proportional. Now when I go on my calculator and I do 8 divided by 5, I get 1.6. And when I do 4 divided by 3, I get 1.3 repeating. This does not equal that. All right, so this would be no, not similar. And the reason for that is sides are not proportional. All right. Then we've got this next one. We've got D. So again, we'll look at the similarity statement to check. So we've got that AB goes with XY. And looking at this triangle, you can see that we're probably going to attempt to use a side, side, side. We've got 3 sides of all the triangles. We don't have any angles. So we're going to attempt to use a side, side, side. And then we've got BC goes with YZ. And then we've got AC goes with XZ. All right, so let's set up our proportions. We'll label it triangle 1 and triangle 2. We've got 9/6. We've got 12/8. And we've got 15/10. So when I do 9 divided by 6, I get 1.5. When I do 12 divided by 8, I get 1.5. And when I do 15 divided by 10, I also get 1.5. So these are all proportional. So we could say that these are similar by side, side, side. Because all the sides are proportional. So now we're going to go ahead and take a look at E. So let's kind of highlight the sides that go together. We've got A and B. And that's going to go with X and Y. All right. And then we've got B and C goes with Y and Z. Okay. So we do have 2 sides. However, if you recall, when you're trying, we look and we're like, okay, well, we've got 2 sides and we do have an angle in each, right? However, if we're looking here, it has to be, remember I said the included angle? You'd have to know that that angle is congruent. And unfortunately, we don't have that information. We know that this guy's 45, but we don't know what the value of the ABC triangle is for that angle. So this one, we can't. So we could just say not enough info. All right. Cool. because we don't have side, angle, side. You either need side, 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 angle, angle, or side, 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 angle, angle, or side, angle, side. We don't have that. All right, so now let's try F. So let's try the, to find, we look at this ABC triangle, all right, and we've got 30 and 100. Well, we could figure out this missing angle, right? We could do 180 minus 30 minus 100. Which is going to give us 50 here. All right, and we're going to do 180 minus 50 minus 100, which is going to give us 30. And if we look at the similarity statement, A is supposed to go with X. You can see they're both first. Y is supposed to go with B because they're second. And C goes with Z. All right, and remember with angle, angle, we only need two angles. However, if you know two angles of the triangle, you know the third automatically because you do 180 minus the two angles. So this, we could say, yes, they're similar by angle, angle. We got these two angles congruent. We got these two angles congruent. And then the third one is just automatically congruent. All right. So let's go ahead. It says find the value of X in each pair of similar triangles. All right. So we have to go ahead and try and set up a proportion. Now, for this one, they didn't give us a similarity statement, okay? However, if we look, you see how these two angles or these two angles here are congruent, right? And these two angles here are congruent. And these two angles here are congruent, right? So you could see that those go together. Now, that means that the sides opposite them would go together. So this one goes with that. And X goes with 15, right? Because that's opposite the red. And these ones are opposite the green, okay? So we could set up our similarity statement now. We got our highlighted colors in there. We'll do triangle 1, triangle 2. Or not even similarity statement, I'm sorry, our proportion. So we'll do 27 over 10 equals X over 15. So go ahead, solve that. So you should get, never mind. You should be getting 405 equals 10x. Divide by 10, and you should get 40.5. All right. So now let's check out this next one. So one thing on these, you could show that these triangles are similar by looking here. They share an angle. And then since these guys are parallel, you know that these angles are congruent because they're corresponding. All right. So basically we know that these are similar by angle, angle. That was the same situation here. We had three angles congruent. This was similar by angle, angle. Okay. So we're going to go ahead and try and set up a proportion here. Let's see. You've got, all right. We've got this side goes with this side, right? And then this side goes with this side. The 4 actually is totally useless here. We don't need that. So we'll go ahead, we'll make the big triangle, triangle 1. So we'll do 15 over 5, and then we do x over 3. So go ahead and solve that. So you should get 45 equals 5x. Divide by 5, and you should get that x is 9. All right, so let's take a look at C. Again, we're going to use these angles to figure out which sides go together. The side opposite these congruent angles are going to be corresponding. Okay, so that means that the 15 and the x go together. And then we look here. The 10 would go with this missing bit of information. However, I do believe this 12 is supposed to be here. We could write that. Or let's see. I actually don't know where the 12 is supposed to go. It's supposed to go on one of these. So I guess we'll just make a decision. How about we can just put the 12 there? It's kind of unclear where that 12 is supposed to go. No, you know what? I take that back, because looking, this one's smaller, so it should go there. That was, you know how the things get shifted when they print. Ooh, I'll put the 12 right there. So change, oh my goodness, I keep thinking I'm doing it in white. So change that on your paper, move the 12 up there. So anyhow, now we also know that these angles are congruent because the third angles have to be congruent. If the other two angles are congruent, so we've got these sides opposites go together. We'll label this triangle 1, triangle 2, and we'll do 15 over x equals 20 over 12. Go ahead and solve that. So you get 180 equals 20x. Divide by 20, and you get 9. All right, so for this last one, see if you can set up a proportion and solve. So when you're trying to figure out which sides go together, these are congruent, so you know that they go together. These angles are congruent, so their sides opposite go together. What I mean by opposite is like right across. You see how like right across, that means that those are corresponding. All right, perfect. So we'll label it triangle 1, triangle 2. If you labeled it differently, no worries. You should still get the same answer. 14 over x equals 21 over 12. You cross multiply 12 times 14 gives you 168. 21x divided by 21. And I got 8.